Now we will discuss the next differential operator, that is Laplacian. This is single operator that is composite of gradient and divergence. So the Laplacian, first statement that we can write regarding that, it is composite of gradients and divergence. It can be defined as divergence of gradient of field. So what we can write in notation form, divergence of gradient of V, we can write like that, and further it can be simplified as dot product del square V. This is Laplacian. So that is single operator that is composite of divergence and gradient, and it can be written as like that. Now in Cartesian coordinate we can write it in Cartesian form. We can write it del square V as del square V with respect to del x square, del square V with del y square, del square Z with del z square. We can write like that. What we can observe from here, this is a scalar field, and gradient of scalar field, gradient transform the scalar field into vector field. So this is vector. The divergence of vector will give you a scalar field. So what we can say in case of Laplacian, Laplacian of a scalar field is another scalar field. It means this is a scalar field. And in case of cylindrical coordinate, we can write Laplacian of field is, Laplacian of scalar field is, just I am writing the formula, del over del rho, rho is multiplied here, V over del rho, and plus 1 by rho del square V over del phi square plus del square V over del z square. This is partial derivative, so just I am pronouncing it del. Now in case of spherical coordinate system, we can write the Laplacian of V, Laplacian of scalar field V is equal to 1 by radius of the sphere square as r square d del V over del r, like that, plus 1 by r square sine theta, and this term we explained in previous case, curl, why this is here, del over del theta and sine theta del field over del theta, plus 1 by r square sine square theta del square V over del, I think it is phi, yes, it is phi square. So this is the full formula in case of Cartesian, cylindrical and spherical coordinate for Laplacian of any scalar field. Now I want to summarize of the differential operators. I will give you few points that is very important. The first one is related to the divergence, that is a vector field is said to be divergence less if the divergence of field is 0. Is said to be divergence less if divergence of field is equal to 0. This is named in another way. It is solenoidal. So either you can say solenoidal. If it is said in the question that show that the field is solenoid, then you have to show that the divergence is 0. Or if it is said prove that it is divergence less, it means you have to show the divergence of field will be equal to 0. Second point, field is said to be conservative. Said to be conservative if its curl is 0. It is also named as irrotational. So in the exam, GATE exam or your academic home exam, it is asked show that the field is conservative. It means you have to show that the curl of the field is 0. Or if it is asked show that it is irrotational, it means you have to prove or show that the curl of the field is 0. Or non-rotational, or and third point, any scalar field or any scalar is said to be field are only scalar, said to be harmonic if its Laplacian is 0. So if we find the Laplacian and we get it is 0, then it means that is only harmonic. The next point that we should note down is the divergence of curl of any vector is 0. So you can write the divergence, this is divergence, the divergence of curl of any vector field V is is 0 always. So note it down. If there is asked directly in this way, you don't have to worry about that, memorize it, just put it 0. Now the next point that is very important to note down, the curl of gradient of any scalar quantity is 0. The curl of any scalar field is equal to 0. Okay, so note it down like that. Curl. Now the next point is, okay, fifth point is the curl of gradient of any, okay, if we are considering V as a vector, then consider here any another field F. The curl of the gradient of any field is equal to 0, since gradient is for scalar field. Okay, so you can write it, curl of gradient of any field is equal to 0. Okay, next point that we can note down, gradient of divergence of V. Next point we can note down, the Laplacian of field V is equal to the gradient of divergence of V minus curl of V. So in another form we can write gradient of divergence of V minus curl of, this is curl of V. This is Laplacian of V.